Greetings and salutations. We are looking at prime numbers today. So a prime number is a whole number greater than 1 that cannot be divided by any whole number other than 1 and itself. So prime numbers, there is one very special prime number which we start with, which is 2. 2 is the only even prime number. After that, we would then see prime numbers ending in a 3, a 5, and I'll come back to that in a minute, a 7, a 1, or a 9. Okay, 5 is the only number that will end in a 5 that is prime. Everything else would be on the 5 times table. Okay, 1 is not a prime because it's only got one factor, hence the sentence saying greater than 1. 9 is not on there, which is a very common misconception because 9 is on the 3 times table. People get into that 3, 5, 7, 9, 11 because of being odd numbers, but just be mindful, it can only be divided by 1 in itself is what a prime number is. If you have been taught by Miss Chapman or by others that are being Miss Chapmanified, one way in which we can spell prime, what is this pen about, is to remind ourselves, instead of an I, we put an 1 and the ME for me, so 1 and me, 1 in itself. Okay, on here, so we've got prime numbers, so knowing the divisibility tests will help you quickly. Okay, so if you have a set of numbers, what I would normally teach is, if you've got those numbers, you can write them out, and then I would say get rid of anything that is even unless it's the number 2. Then I would get rid of anything on the 5 times table unless it's 5. Then I would look at anything like square numbers that I know, get rid of them, and then get anything rid of the 3 times tables. If you get rid of all of those, then you will pretty much be left with prime numbers. Okay, so there are some more of the divisibility rules. Okay, but again, from the previous slide, if you think about get rid of the evens, get rid of the 5 times tables, get rid of the 3 times tables, and then get rid of anything that might have mopped up like square numbers. After that, you'll be left with what you need to be left with. Okay, so there's a divisibility rule there for 7, but again, keep it simple. Get rid of your 2s, get rid of your 5s, get rid of your 3s. If need be, if it's a question saying is this prime or is this divisible by 7, the very quick way of doing it is just do that value divided by 7. If it gives you a whole number, fantastic. If it gives you a decimal number, then you're thinking, hang on a minute, maybe this is prime. Okay, a whole number would mean it is on the 7 times table, so you can discount it. If it is a decimal number, then you'd say maybe this is prime. Right, you've got some examples to go about. Okay, so you're looking at then which of the following numbers are on the 2 times table, the 3, the 4s, the 6s. Some of these numbers might be on more than that, so you would then write down what they are. Okay, and there are your answers. On here, so list the factors and decide if the number is prime or not. Okay, so for each one of these, I would write down, okay, so I know my factors of 5 is 1 and 5. After that, there's no other factors, so yes, it's prime. And then I would do the same for those. Okay, and there's your answers. Okay, so most CR style questions. So we've got here, write down all the prime numbers between 10 and 20. So again, use that strategy that I said about, list out your numbers 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Get rid of your evens, get rid of your 5 times tables, get rid of anything that might be on your 3 times tables, and then you will be left with your prime numbers. Okay, Reminder that the word sum means addition. And then you've got that final question to have a look at. Off you go. Key thing we talked about in one of the slides earlier, 2 is the only even prime number. Yes, Lewis would then be right after that because everything else is odd, but in his statement he is incorrect because he has forgot about the number 2. And that is prime numbers. Many thanks.